Hello guys, my name is Gennady and welcome to Software Development with Swift YouTube channel. On this YouTube channel I'll be discussing many software development topics with examples in Swift and iOS. Though I'll not be focusing on specifics for iOS or Swift, just how to bring generic software development tools, patterns, designs, topics, and so on in iOS and Swift. So let's dive straight in and see what we'll be talking about today. Today is the beginning of a long series of video moving towards learning more advanced functional programming. But before starting to learn more advanced from functional programming, like say high order functions, currying, and so on, first thing first, we need to lay some ground of what are functions, what are the importance, where is the place for the functions in our day-to-day development. Because if we will not understand the true value of a function and why the function is important, then most probably will not get the most out of the principles of functional programming. Thus, in today's video, we'll focus on motivating why functions are important, where is the place for a function in our program. In this video and in the next ones, I'll be making many comparisons between functional programming and OP, at the same time between functions and classes. And I mean this not in any way to say that functional programming is better than OP or something like this. Of course, there are a lot of articles and videos that try to say this, that functional programming is better than OP and it will solve magically something for you. But as with all silver bullets in software development, that is not true. It all in the end depends of a programmer, thus of you. If you write good OP, you will have no problems with your apps. If you are poor at writing OP, then functional programming will not save you. You will still write poor functions if you write poor OP. So let's start with some motivation. First thing, I think most of us, if not all of us, started programming in some OP language, and most probably it was Java. And if you recall, when learning OP, it's everything about classes, objects, inheritance, design patterns, encapsulations, and everything about OP. But very, very little about functions. At the beginning, we learn about functions that we can use them as getters and setters, and then there were other util functions, but will not very much learn about the importance and the meaning of functions. We will most probably just learn the syntax of a functions, about the parameters, return types. But with time, at least for me, and for sure you also saw, that all of the behavior and business and all of the moving parts are in functions. Even though you can say, sure, that functions are part of classes and therefore the behavior is in classes, but nevertheless, if you move at a narrow scope, all of the logic is in functions, and therefore all of the bugs will appear here, because bugs appear where there are moving parts, where there is logic and business. And therefore, if we don't design well the functions, then for sure we'll have bugs, even though we design well in terms of OP, where class interacts and so on. Before making a case for the point number 3, we want to look at our applications from top to down levels. At most abstract level, we have our deliverable, be it on iOS, it's an IPA, on Android APK, and other form of application different. For framework, it's just framework. And this will be the first level. The next level, we will have the modules, the other dependencies, the frameworks, the bundle, and so on in our application. So this is the next module next level of abstractions, or we have modules just as black boxes with some public APIs. If we look inside the module, then we'll have here a multitude of classes, protocols, and some data types. And next, the interesting part is if we take a look into classes. And if we take a look into classes, we'll see that there is data expressed through class properties, and the logic is expressed to function. As we can say that at the highest level part is the deliverable, and at the lowest part will be the functions and data and how those communicate between themselves. Let's say more like data and the behavior over data, like transformation of data. Actually, this is what a program about. But at least as we will see, at least I don't know what is the other way to program behavior other than through functions. So with some prior or warm-up motivation being put in place, I think it's very valuable to create a definition for what is a function to help us through day-to-day coding. I found myself that the independency of dependent of what definition I have for some language feature and so on, then I will use that feature in a way or another. And this is absolutely the case also for function, and as we will see is the case also for classes. And the first definition, the most simplest one and easy to remember and easy to apply, is that a function is a block of code. The problem with this is that we will end up creating functions just for the sake of removing duplicated code. Whenever we see a duplicated code, we will get this code, put it in a function, and call the function. Even though the code that is duplicated might not be correlated, on there is no well-defined behavior or logic for this correlated code. So a function in itself that encapsulates this duplicated code will end up existing in system just for the sake of removing duplicated code, and it does not have any other more concrete meaning in the system. And with this definition, we will end up making quick patches, removing duplicated code through functions, while it can be very useful just to stop a bit and think why in the first place we do have duplicated code. Maybe there are some issues, problems with our design before deciding that we need to put this code in a function. What I like more to think of a function is kind of the same way I think of a class. Function encapsulates a given well-defined reusable behavior, and for classes we usually use kind of the same definition, that we create a class with a clear purpose in a system. It has some responsibility, some behavior that we want encapsulated in a class. We don't create classes just for the sake of removing duplicated code. Well, maybe we do for some, like helper classes, util, and so on, but those are very, very little by count, not comparable with function in any way. And I think with this definition, it is very helpful because when we create a function or we want to create a function, we think of what is the primary purpose of these functions to exist, necessarily in the whole program, but maybe at a smaller scope, let's say the scope of a class. Does it make sense to be here for this function? What is responsibility? What's its behavior, and so on. Like we put more thought into getting a function. And since we have talked about the behavior, let's see what is behavior and what's not. And as I said previously, the behavior will be expressed through functions. At least I don't know other way how to call behavior other than through functions. And what is not in behavior, this is pure data. And many languages provide some primitive types like int, double, string, and so on, and a way to combine those types in a set, array, dictionary. And then the language will provide a way to create a custom type in Swift, it will be like through struct and enum. And see that there I didn't put classes, and I emphasized explicitly value type for struct and enums. What I mean by this? So a struct or enum will be a value type if it follows value type semantics. And this means that struct or enum contains only pure data, thus like other data structures, other primitive types, or other value types created through struct or enum. If a struct or enum contain behavior, and behavior something like this, then it's no more value type. It's more like a class, and like spoiler for the next slides, it will act more like as an object and necessarily as a value type. And then what about classes? If you look into example, we see that we have 3 properties defined, 1 through 3, and 3 functions defined, also 1 through 3. And if you look at some higher level, we see that properties, we can group them in a block that represents the data, and the functions, we can group them in a block that represents behavior. And with this, we can say that classes are actually the means of grouping the data and behavior together, and actually the data is correlated with behavior. This behavior is meant to make changes over the data, and the data is meant to respond to the changes expressed in the behavior. So there is a strong correlation between data and behavior. In some way, data plus behavior defines an identity or an object that will be created from this example. And if you take one component out, then it will no more be an object, and there is no more need for a class. If we take out behavior and we have only data, then we can say that, well, this is a value type because there is only data, and maybe we can use structs. And if there is no data and only behavior, then, well, class will act more just as a namespace to group the functions, and we can even put the functions being a static, because actually there is no point in creating an object from this class because there is no object. Thus, we can say that any class is created from or contains data plus behavior, or the behavior in this case, as explained, will be expressed through functions. So it's data plus functions. So at least what I like to think of an object is that an object glues together data and the behavior over it. And this definition is somewhat different from the most simplest one, as with what is a function, that the object is a concrete instance of a class. And for the same reasons, this definition is very easy and very easy to grasp and apply. Just when you want to create an object, what do you do? You define a class and then instantiate the object. Because the definition tells us so. An object is a concrete instance of a class. But if you think of an object as something that glues together data and the behavior over it, then suddenly there appear much more options on how to create an object. As I said previously, with struct and enums, we do create this glue together, glue between data and behavior, then we can see we have an object. And even further, we can create objects for functions, because functions at the same time, those can glue together data and the behavior over it. This feature of functions we will see in further videos, but as a quick explanation is that we can have variables declared inside of a function, and if our function returns other function, basically acting as a constructor for another function, this function can capture the internal variables, and basically we will have the glue between data and behavior over it. So as a conclusion for this video, we have seen that functions are actually very, very important, and they have a very important and specific place in our program. I will say one last thing is that if you have bad functions, you'll have bad classes, mostly for sure, because as you have seen, all of the behavior is expressed through functions, and if we design them poorly, then for sure we'll have poorly designed classes. Before concluding this video, let's talk a bit what we'll be covering in the next video. Since in this video we've covered the importance of a function and why we should care about functions, in the next video we'll be starting looking over how functions are structured and what are the inputs and outputs of a function. Once quick notice over the next videos for the inputs and outputs is that actually a function can have its inputs not only through function arguments, and a function can have its outputs not only through return statement. And this has quite big implications in overall design of functions. But we'll discuss it in the next video. Thank you for staying with me till the end of this video. See you next time. Bye.